Good evening, everyone. Welcome to the session. Just we'll wait for some time, let others join, and then we'll begin with the session.
Okay, sir.
Good evening, everyone. Hope my screen is visible and I'm audible. So, welcome to the first problem-solving session for the course Environmental Degradation in Surface Engineering. The course code is NOC 25 MM67. This is the first live session. The course instructor for this course are Professor Josna Datta Muzumdar and Professor Indranil Manna from IIT Kharagpur. My name is Amey Dukle. I am the Prime Minister Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. So, how this sessions go is basically we try to uh, uh, show you the previous year question paper, previous year assignments. So, using the previous year assignment as a reference, you'll be able to solve this year's assignments. So, that is what the basic thought process behind it is. So, if you have any doubts, if you have any technical queries regarding this year's course, we'll try to help. But we will not answer this year's assignment directly. So whatever will happen will be happening like in hints basically. So with that, we'll just start with the presentation. So yeah. A few important things. This live interactive sessions are to boost your performance. They are not compulsory, but they are highly encouraged. We request you to be respectful in the chat, uh, and like you can ask your questions by unmuting yourself, or you can wait till the end of the lecture where we'll be waiting for the assignments. The all the videos will be uploaded on this YouTube channel. You can see the link, and the link will also be uploaded on the NPTEL page as well. So as we are done with that, I think so my bandwidth doesn't allow me to keep the video on, so I'll just keep the video off. We'll start with the session. So we'll be discussing practice assignment one, and then we'll be taking your question and answers. So this is the course outline. Per se, this is a 12-week course. In this is the first week. We'll be going into introduction to environmental degradation of material and its classification. So next week again we'll have failure analysis. Then again we'll have like surface initiated chemical degradation. Then mechanical degradation, general mitigation, prevention strategies, and so on and so forth. So today is a very light week. The questions are not that difficult. So we'll start with it. The first question is, what exactly is surface degradation? So is it the breakdown of material? It is the breaking down of the top layer of material. It is the degradation of the mechanical properties of the material, or all of the above. So any guesses? So the answer is breakdown of the top layer of material. So basically, since it's a surface degradation, the surface is basically the topmost layer of the material. So basically, in the surface degradation, what happens is the topmost layer of the material is broken down. So that is why it is called as surface degradation. Um, Moving to the next question. So which of the following is the most appropriate answer regarding surface degradation in metal? So what are the characteristics basically of uh, a surface degradation in metal? So this is what the question is asking. Is it color fading? Is it electrical resistance? Is it bending of structure, or is it rust formation? So the answer here is rust formation. So basically what happens is here um, do due to the degradation, surface degradation. There is rust formation happening. Moving to the third question, what is the protective strategy suggested for combating surface degradation? So, is it chemical additives? Is it heat treatment? Is it coating or mechanical reinforcement? So, basically, when we are talking about the surface, obviously, it will whatever the strategy will be mainly based on the surface level. So, whatever like chemical additives, so alloying, basically alloying is done into the complete frame, complete metal. It is not just done on the surface. Similar with the heat treatment. Heat treatment is done over the entire microstructure. It is not just done on the surface, but you can see that coatings are basically done only on the surface level. So the answer here is coatings. Moving to the fourth question, what is essential for mitigating failures similar to surface degradation? Surface hardening, regular repainting, timely maintenance, enhanced product design. So the answer here is surface hardness. So basically, what happens is when you um, increase the surface hardness, uh, it becomes more resistant to the wear. So basically, what happens is when the surface is hard enough or surface is strong enough, it cannot be penetrated by mechanical force. More mechanical force is required for chemical degradation. So that is why the surface hardness is one of the major parameters in um mitigating surface degradation. So the fifth question, which is the most prevalent unit for measuring of surface roughness? Is it centimeters, meters, micrometers, or nanometers? So the answer here is nanometers. So the entire surface and the subsurface layer is basically in you can say is up to zero point 0.1 microns. So the entire thing is about 100 nanometers. So all the parameters are basically given in nanometers, basically surface level measurement. Moving to the next question, which is the method mentioned in the initial approach to detect large surface defects: destructive testing, non-destructive testing, surface visualization, fatigue analysis. The answer is surface visualization. Because as you can see, the what you want to do is when you want to detect large surface level defect, what you want to do is basically you have to visualize what how the surface looks like, and that is why the first thing you do is surface visualization. So moving to the next question, what is correct about Bhopal gas tragedy? So was it the leakage of methyl isocyanate gas, refrigeration system closed for saving the cost, gas scrubber not functioning properly, all of the above? So basically, Bhopal gas tragedy happened in 1984. It was one of the greatest industrial tragedies in India. So there is a factory, there's a company named Union Carbide. So there was, in the middle of the night, there was this gas leak, and a lot of people died. And even after so many years, even the survivors have had some problems with their breathing functionalities. So it was one of the greatest tragedies in India. And there's there are a lot. When the investigation actually happened, many of the things were found out. So basically, the answer is all of the above. So basically, the main impact what happened was methyl isocyanate gas was leaked, and that caused deaths. But why it happened is because they had closed the refrigeration system to save cost, and also the gas scrubber. So basically, this thing that is used to remove the poisonous items from the exhaust gases, that was also not functioning properly. So it was the immediate, you can say, the reason of the tragedy is the leakage of methyl cyanide gas. But the investigation revealed how the failure happened. So this was the like the correct sequence, or this was the like correct other factors that affected the tragedy. So the answer is all of the above. Moving to the next question, what should be considered when evaluating the effectiveness of different characterization techniques? Hello. So yeah, moving to the eighth question, what should be considered when evaluating the effectiveness of the different characterization technique, their associated costs and effectiveness across various across diverse contexts, the speed of implementation, the popularity of the method, and the simplicity of the procedure? So the answer is their associated cost and effectiveness across diverse contexts. So basically, what the question is asking is, when you are given the different characterization technique, you are an engineer and you have to
Hello,
select the
can
appropriate.
can you hear me?
Yeah, hello. Yeah,
Yeah, this is Satish here. Can you
yeah,
go through from question number one because I don't have a
yeah, yeah, sure. Just
yeah.
I'll just change the slides. So
Okay.
there are the basic things. I'll not bore you with this. So I'll just start with the first question. So the first question. Just keep in mind, these are previous year questions. I have not made them. So and the answers also, some I have not made them. I'm just found out there are some answers which even I may not agree with, but those answers are given. They were given last year, so I'm just telling them as it is. So there might be some controversial answers. So in that case, we'll discuss it. But these are last year answers, so I'm just giving you whatever the course instructor has given. So there might be some controversial answers. If there are controversial answers this year, you have to use the discussion forum to raise your concerns. So with that, I'll just begin with the session. What exactly? So the first question was, what exactly is surface degradation? The breakdown of a material, the breakdown of the top layer of material, degradation of mechanical properties of material, all of the above. So the answer is breaking down of the top layer of material. So basically, when we are talking about the surface level thing, the surface degradation, what we are concerned is with the top layer of the material itself. So the surface degradation this one corresponds to the breaking down of the top layer of the material. The second question, so which of the following is an appropriate answer regarding the surface degradation in metals? So it is asking is, what is the characteristic? How will you identify what surface degradation in metal is? So, what which of the following scenarios is a surface degradation in metal? So basically, whether it is color fading, whether it is electrical resistance, whether it is bending of a structure, or whether it is rust formation. So basically, rust is the only one which is a surface level phenomena which suggests that yes, the material has degraded. So basically, color fading is can happen due to like the coating might have failed or something, like likewise. Even the electrical resistance, the phase for it's the entire phase for phenomena. It's the entire cross section of the metal is involved. Same with the bending of the structure. So the answer here is rust formation. So the third question: what protective strategy is suggested for combating surface degradation? Whether it is chemical use of chemical additives, whether it is heat treatment, whether it is coatings, or whether it is mechanical reinforcement. So the answer here is coating. So basically, chemical additives, like if you put some alloying, like what how you do in stainless steel, the entire you have to do it across the entire face. You cannot just do at the surface level. See, likewise with heat treatment. So when you do forging or various other manufacturing process, you have to do heat treatment. So that is also a completely phenomena. It is not just done at the surface level. Similar with mechanical reinforcement, basically when you are adding another backing plate or a backing layer to increase the strength, again that is a phenomena. It is not just done at the surface level. So only thing that is done at the surface level to improve the surface properties is coatings. So the answer here is coatings. What is essential for mitigating failure similar to surface degradation? Surface hardness, regular repainting, timely maintenance, enhanced product design. Uh, the answer given here is surface hardness. So basically, the logic here given here is basically if you have a surface hardness, if you have a very hard surface, so when a surface is hard, it is resistance to it provides a resistance to mechanical action. So anything that can damage the surface due to mechanical action is avoided when the surface is hard enough. So that is why the answer here is the essential for surface the strategy that is essential for mitigating failures similar to surface degradation is enhancing the surface hardness. So yeah, this is one of the controversial questions. The most prevalent unit for measuring the surface roughness is centimeters, meters, micrometers, nanometers. Um, the answer given here is nanometers. So basically, just to give you a context, so a surface is basically whatever is there within the first 100 microns. So this surface, and then there is so there is a face, there is subsurface and the surface. So what we are bothered here with surface engineering is basically the surface and the subsurface, which is in the first 100 microns. So normally they give the roughness in microns. You might have heard the term microns. In more scientific studies, or like in a very high ultra precision engineering application, they obviously give the surface in the nanometers range. So here the answer should have been micrometers, but they have given nanometers in the coursework. So I'm just repeating it here, but in logically the answer should be micrometer. Moving to the question number 6.
Yeah, what is
Which
the question is which can be we can consider it is a micrometer or nanometer?
So basically it should be micrometer. So they have given nanometers, so I just put it here nanometers, but the answer is micrometers. So I'll correct it to micrometers in the slides basically later. Just I just I was in a hurry, so I just copy pasted the what we got in the previous year questions for this presentation. But usually the answer should be micrometers. Okay. So wherever you go in engineering, you will always find surface roughness in microns only.
Yeah, I have observed. Yeah, thank you.
Okay. So moving to question number 6. which method is mentioned as the initial approach to detect large surface defect: destructive testing, non-destructive testing, surface visualization, fatigue analysis. So now, destructive testing, basically the tensile testing, compressive testing, in which the sample is destroyed. Non-destructive testing is basically the ultrasound-based techniques, XRDs, FTIRs, and all those things. Um, Surface visualization is basically you're using a probe, ultrasonic probe, or you're using surface profilometer to actually visualize the surface. And fatigue analysis, basically you run through fatigue load, and you calculate the your fatigue. So obviously, when you are doing it to detect the large surface defect, your answer should be surface visualization. Um, I hope these answers are clear. The next, so which of the following is correct about the Bhopal gas tragedy? Leakage of methyl isocyanate gas, re- refrigeration system closed for saving the cost, gas scrubber not functioning properly, all of the above. So
PCA?
basically, Bhopal gas tragedy, if you might not have known, it is a biggest industrial tragedy in India. So it happened in 1984 in the month of December in Bhopal. There is a factory, there is a company called as Union Carbide. So there was a leakage of methyl isocyanate gas, and there was like thousands of deaths. The exact number is basically it is disputed, so it's irrelevant. And even though people who are alive today as well, they are having respiratory issues. So it was one of the biggest tragedies of all time. So the what was found as the basic main cause, or the main thing that caused the tragedy, was obviously the leakage of methyl isocyanate gas. But what happened, so when the investigation was done, it was found out that they had closed the refrigeration system to save the cost. And because of that, there was the heat because the heat generated by the gas, um, there was some wall, there was rupture of some wall because of the heat. And then the gas came out, and the entire city, it went through the entire city from the fumes, and there was death. And it was also found that the gas scrubber, which is supposed to actually prevent this in the at the exhaust level, was also not functioning properly. So what happened in the Bhopal tragedy is, where there was leakage of isocyanate gas, there was also refrigeration system was closed, and the gas scrubber was also not happening. So main cause was refrigeration failure. The stopgap was also not functioning properly, that is the gas scrubber. And what eventually happened was the leakage of the gas. uh, Moving to the question number 8, what should be considered when evaluating the effectiveness of different characterization technique, their associated cost and effectiveness at the different contexts, the speed of implementation, the popularity of the method, the simplicity of the procedure. So the main thing, the first thing that is done. So what the question means wants to ask you is, you are an engineer, and you have some problem, you have found out there is some problem with this material. So then obviously there will be tons of characterization technique that you will be doing, you can do. So what it wants to ask you, what will be the factor with which you will choose the characterization technique. So the first thing, or the main thing, is basically you will find out the cost, and also find out the effectiveness across the context. So basically, if you want to, if you are bothered with the surface level phenomena, so what you will be first, if you are focused with the surface roughness, then all what you will do is you will do the surface profilometer. You will use the surface profilometer. You will not go into FTIR and find out what are the functional groups on the surface, what are the greases on the surface, or all those things. What you will do is, you want to just find out the roughness. You will use the surface profilometer, and you will find out the roughness. So that is what the question asks. So what will be the first factor? What will be the major factor that you will be considering when selecting the um, characterization technique? It will be basically, you will be finding out its effectiveness, and also their associated cost. So the next question is basically, the true contact is typically limited to what percentage of the nominal contact area? 0.1%, 1%, 25%, 100%. So uh, there is something else, contact angle, and there is two contact and the nominal contact. So there will be, so we all know that there is, the your surface has SPTs, right? So I'll just draw and show it to you. So your surface basically is not smooth; it has SPTs. So this is your first object. This is your second object. So when you are looking from far, it will basically look like as if both the objects are in contact. So this is called as the nominal contact. But the true contact is basically happening at only like a fraction of the real contact angle. So when you will see here in the nominal contact, and this is the true contact. Uh, so basically, typically, what we see is the true contact is basically only 1% of the of the nominal contact area. I hope I'm clear. Moving to the 10th question: what is the environmental impact of tire deterioration? Release of particles that pollute the environment, release of harmful gases, increase road accident, increase in fuel consumption. So basically, what happens is, the tires over the period of time when they run for around 5,000, 10,000 kilometers, you will see that their grooves are basically gone, and the tire has become like there is no grooves, and it has become like a flat. So what happens is, because of that, you don't get a very good grip on the road. So one of the main thing happens that over the period of time with the wear of the tire, your braking distance increases, because since there is a less contact between the road and the tire surface, what you will see is the braking distance will be increasing. So if a car could be brought to halt within like 100 meters, it will take around 200, 300 meters if the tire is worn out. So what is the impact is basically there will be increase in the road accident. So moving to the 11th question: what does the course aim to explore in relation to material
Yeah,
surfaces?
I have a
Characterize.
doubt on. Yeah, I have a doubt on question number 10.
Yeah, yeah, sure.
Yeah, why not the release of particle to pollute the environment?
Yeah, that is also there, and there is a release of harmful gases also. So it's not like there is only one thing that is happening, but like
Yeah,
this is
that
one of the
then
major
then
factors.
that is you were asked about the environmental impact, right? It is not a personal impact.
Oh yeah, that's true. They should have done that. So like I told you, this is uh, these are the answers I've just given face to face. So actually I should. It's, I told you right. There are some answers even I'm not satisfied with them. So I just put them, and I kept them open for discussion. So when you guys are also happy with it, I changed here. So I'll upload this in the drive. So don't worry about it. So yeah, what you are saying is completely sensible, and yes, the release of particles actually causes the pollution in the environment, and it will basically lead to the thing. But road accidents will also happen, and there will be also release of harmful gases, because the heat will generate. So and your tire is made up of like carbonaceous material, rubber. So that will also happen. So lot of factors will be happening. So yeah, the major thing is release of particles that pollute the environment. Uh, so moving to the 11th question: what is the course aim to explore with relation to materials, surfaces, characterization technique, coating, procedures, surface modification methodologies, all of the above? So yeah, the answer is all of the above. Um, this one was the question last year, so just imagine how easy right it is going to be. So yeah, moving to the next question: what is one of the objectives stated for improving the quality of material used in automobiles, increasing environment sustainability, enhancing aesthetic appeal, uh, reducing manufacturing cost, uh, improving speed and performance? So which of the of by improving the quality of material. So basically, what will happen is, if they improve the quality of material, it will last longer, and since it will last longer, what will happen is you will need less spares eventually, and that will basically, since less spares are required, eventual the outcome is going to be increase in the environmental sustainability. So moving to the next question, what are the primary influences on the material degradation? Color change, sound and smell, environmental conditions, mechanical strain and chemical reactions, uh, the electrical resistance, magnetism, light, shape, size, weight. So what is the primary influence on the, what are the primary factors that influence the material degradation? So like color change, sound, smell, basically these are the impacts, these are not the influential, so these are not the cause, these are the effects, you can say. Color change or smell or sound, basically these are the impacts of material degradation. uh, Likewise, like shape, size and weight, these are like the geometrical factors, these are not the, like, they don't like they do have a sort of influence, but they are not the main factor. The main factor is obviously the environmental condition, the mechanical strain, so mechanical, how much loading is happening, and the chemical reaction that are microchemical reaction that are happening there. So these are the main parameters basically that cause the material degradation when it comes to the surface material degradation reasons. The 14th question: which of the following is the most appropriate answer considering the significant financial consequences of material degradation? Manufacturing cost increase, increased labor cost, expenses for maintenance and replacement increase, increased fixed costs. So the answer here is expenses for maintenance and replacement will be increased. So obviously, when there is material degradation, you have to take that part out of service. So what will happen is you have to do the maintenance and you have to do the replacement. So the answer is, in terms of financial consequences, your maintenance and replacement cost will be increased. 15th, why is it important to address material degradation? To increase the product size, to maintain high standards of performance and environmental sustainability, to improve product aesthetics, or to enhance market competitiveness. So the most important thing is to maintain high standard of performance and environmental sustainability. So basically, if you are not focusing on material degradation, what will happen is eventually your like product, you will have performance issues, and you have to you change the parts, or have the, like, change the you increase the spares that you are using. So eventually what will happen is the environment sustainability will also get affected. So the answer here is to maintain the high standards of performance and environmental sustainability. Question number 16: what role does temperature play in material degradation? It has no effect. It increases the rate of corrosion. It stabilizes the material properties. It increases the surface roughness. So basically, what happens is, at a higher temperature, you might have heard the Arrhenius equation. Like there was something called as activation energy, which was KT. Uh, uh, so what happens is, when the temperature increases, the process which somehow which uh, like at higher the temperature, less energy is required to basically cause any chemical reaction to occur. So basically what will happen is, at higher temperature, the activation energy for any chemical reaction gets lowered. So what will happen is, because of the increase in temperature, there will be increase in the rate of corrosion of the material. Coming to question number 17, what is the purpose of 3D optical profilometer? To examine the surface roughness, to examine the thickness, to examine the color, to examine the surface hardness. So the answer is examine the surface roughness. So basically, 3D optical profilometer, it's basically it uses light. So it there'll be a lens, and there'll be like length and the light source. So basically, it will be a laser light. At a particular frequency, it will go. It will be it will be incident on the surface, and then there will be sensors, the optical sensor, lens type sensors, that will take the light. So depending on the surface, depending on the thickness, basically what you will see is there'll be more time. So uh, if the defect is longer, so I'll just show it to you. It would be better for me to show it to you. So from here, there is a light source basically, and then there are sensors here. Assume there are sensors here, and this is your surface. So what it will do is it will incident light. So there will be incident light, and based on the depth, you will have the difference change. So you will get a optical profile of the surface. So that is how the 3D optical profilometer works. So basically it is used to measure the surface roughness. Moving to the 18th question, what is an essential component in management of material degradation? Workforce training, increasing the batch size, establishing a comprehensive scientific understanding, easing the maintenance schedule. So to basically do, for management of the material degradation, the first thing which you have to do is you have to find out what is the cause of it. So you have to establish a kind of comprehensive scientific understanding of the process. So only when you do that, you will be able to manage it properly. By like, you can obviously train the workforce to identify it, but like, you cannot just go on identify keeping the like identification process going on every day. You have to do is you have to find out the comprehensive understanding. So you will get the early signs of the failure, so that you can manage it well. So that is something which is done in the merchant navy. So basically they have the proper understanding of what part can go wrong, what are the early stages of the part going wrong, there's some problem happening. So they have the they train the workforce in the steps, like they'll tell give them a checklist wherein they'll know how a part going wrong looks like. So they have a comprehensive understanding of the a comprehensive scientific understanding of what it looks like, and then by training the workforce, they are able to manage the operations of the ship in a proper manner. So this is how it happens. Um, Moving to the 19th question, what is the percentage range of Indian GDP attributed to losses caused by corrosion? So, is it 0.001% to 0.1%? Is it 0.011% to 0.1%? Is it 0.11% to 1%? Or is it 1 to 10%? So basically, it is, we all know we are not like, we don't do too much of predictive maintenance, and we wait for the material to like fail. This is something which has been an Indian culture for a long time. So we obviously, because of that, there is a lot of high like losses because of corrosion. So the raw losses basically range between 1 to 10%, which is quite a huge loss. Um, and moving to the 20th question, what is the typical trend in efficiency over time of a continuous system? Efficiency increases over time, efficiency remains constant, efficiency gradually decreases, efficiency fluctuates randomly. So one of the continuous system is basically, you can say, not very continuous, but you can say your two wheeler or your four wheeler. So you might have observed that older it gets, the fuel efficiency obviously decreases. So that is one of the thing which we can see, because of the wear which will be happening, because the wear rate, obviously there will be poor, the efficiency uh, goes on reducing. So basically what we can see is, over time in a continuous system, the efficiency continuously decreases. So with this, we have completed previous year assignment 1. If you have any questions, you are free to ask.
From my side, there is no questions.
Yeah, if you don't have any question, you are free to leave. I also don't want to waste your time. It's a very easy course. Don't take too much of stress. Finish your assignment on time. And what else have done?
Exams also will be like same questions will come out, or what is
Similar
there any
questions,
numerical
not
ones?
too many, not difficult questions, very similar questions. So this is a 12-week course, so it will be easy. I won't say these are too easy, but maybe like the level will increase by 4 week 4 week 5. So over there you will see like that level of questions it will come. Not this week. This week is too easy, but week 4 week 5 I've just seen. I'm also yet to completely make the PPTs, but what I saw previous year questions is quite like assignment questions I'm talking about. The level was increasing after week 4 week 5, and that is what you can say is going to happen. You can anticipate that will be a level of questions you will face in your exam. So that will be easy. Don't worry. Even like I recommend you go through the videos once. That will be enough. Not too much of not too much effort will be required. So if you are doing it for your like MOOC courses for your uh, degree, this is a very easy course. I would recommend taking this one.
Yeah, sure. Thank you. Is there any numerical questions also will be there, or what is?
Uh, in future, there are few numerical questions, but they'll be very easy. Like one, like how it is, like basic level of questions where everything will be given. You just have to put it in the formula. There are few formulas which you have to put, but there won't be like very difficult questions like sine. Even like if angles will be there, it will be like theta 30 or 45, that kind of like, very basic questions. So don't worry about the numericals also. But it will be like multiple choice only. It won't be like how we have in gate. That way it won't be. It will be like basic. Uh, and I understand what your question is. Like you want to ask whether it will be like gate where you have to type in your answer. That way it won't be. It will be like multiple choice only.
Yeah. Okay. Thank you. That's all.
If you don't have any question, you're free to leave.
Yeah. Thank you.
since most of the candidates have left the session, I would like to extend a warm regards for attending the session. Thank you for your time. We'll see you next week. Thank you.